Okay, so for our first example here, we have our right angle. This, of course, would be the hypotenuse. The legs, of course, depend on which angle we're looking at. First thing I would find is side Z. How would I find it? A squared plus B squared equals C squared, or taking the square root of A squared plus B squared, you should get 41 inches. How many of you had 41 inches? How many of you didn't try? How many of you don't care? Okay. Let's find angle X. And again, we've got the 41 inches here now, but I want to use stuff that was given to me because I know that was right. There's a chance we screwed up the 41. What?
How is there a chance that we screwed up the 41?
Who knows? But we may have hit something. We calculated that, so we're not totally sure. I mean, we're really, really sure, but it's safer to go back to information that's given because then we know it's right, or it's somebody else's mistake if it's wrong. So we've got the 9, which according to angle X, the 9 would be which leg? Opposite, and the 40 would be the adjacent. So we are looking at a tangent of an angle is opposite over adjacent. And then we fill in what we know. Do we know the angle? No, that is what we're looking for, X. Opposite side is 9. The adjacent side is 40. So now we're looking for an angle. Put the phone away, guys. We're looking for an angle. Okay, we're looking for an angle, so what do we have to do? We do an inverse function. We're going to do the inverse tangent here. So X equals second tangent of 9 divided by 41. Close. 12.38 degrees. How many of you had 12.38 degrees for angle X?
12.68.
I do over 41? Oh, let's try that again. Second tangent 9 divided by 40 might be better. 12.68 is what we want, not 38. How many of you had 12.68 degrees? Perfect.
Whoa, where did you get the 6?
What?
Why is it 6?
6.8 because I punched it in wrong. It's 9 over 40.
I didn't punch it.
So it should be 9 over 40. So once we have that, we could then do, the tangent of y would be 40 over 9. And we could do an inverse tangent there. But I'm going to be lazy for right now, and I'm just going to do 90 minus the 12.68. Gives me 77.32 degrees. I solved my triangle.
You did it without a calculator.
Yes, I did. It's just 90 minus 12.68. So now, over to the second one. How many of you got to the second one?
I figured out what X was.
Okay.
That's it.
X has to be 30 degrees. Very good. Let's find Y. Y is what side here? It's the hypotenuse. 20 would be the adjacent if I'm using the 60. Always go back to what we're given if you can. It's always good policy. So we have adjacent hypotenuse, which is cosine. Cosine of an angle is adjacent over hypotenuse. This is for Y. So we've got the cosine of 60 degrees equals 20 over Y. We're going to put this over 1, so it's going to be 1 times 20 divided by 60, which makes that 40 inches. One times 20 divided by the cosine of 60 is 40. Okay, do you see why it's a cosine? Adjacent hypotenuse. So you put in 60 for the angle, 20 for the adjacent side, and then y. So 1 times 20 is 20, divided by the cosine of 60. Should give you 40. Yeah, once we get this all done, we will.
Why is it equal?
Because 20 is the adjacent side and y is the hypotenuse, so it's adjacent over hypotenuse. Yeah. Now we still got to find z here. Z, just a second. Z is going to be the square root of 40 squared minus 20 squared.
But, okay, is there a way to find, you didn't know that y equals 40, so you can, like, if you did, I know you didn't because you never mess up. But if there was a way that you did mess up, like, your way to find z with stuff that you're given.
Very good question. Could I find z with stuff that I'm given so I don't have to use the 40 that I calculated? Yes, there is. Z, if I go back to my 60-degree angle, z would be the opposite side. And I'm given the adjacent, I'm looking for the opposite. That would be a tangent. Tangent is opposite over adjacent. So I fill in my 60 degrees for the angle. The opposite side is z that I'm looking for. The adjacent side is my 20. Put this over 1. I'm just going to cross multiply. Tangent is 60 times 20 divided by 1. Tangent is 60. Oops. Times 20. Come on. There we go. 34.64. Same answer. Oh yeah, it's a very good point. I usually say don't use stuff that you just calculated. I was trying to be lazy there, but you caught me. Yep. So the question is, what are we going to use this stuff for? Have you guys ever used a theodolist or theodolite?
Say that again?
Do you guys know what a transit is?
It's a train.
What's that? Train?
Transit level?
We're not talking about mass transit. We're talking about transit as a level. Yeah.
Okay, yeah, I've heard of it. I think I've used it once. Nice.
A transit sits on a tripod. You got to level it. And once you get it perfectly leveled, it's a scope that you look through. And you have a surveying stick that has heights marks on it. So you'll look at it here. You'll get a reading right next to the level or a reference point or whatever. It's a known elevation, or it's just going to be the elevation you do everything off of. You get a reading there that might be, 48 inches or whatever. Then you come here. Let's say this reads 48 inches. And you come here and this reads 67 inches. What that's saying is this is 19 inches lower here. Because it's got a larger reading on the stick. It's higher up on the stick. So it's further down to that point. No, because a laser level just gives you a line. The transit actually tells you how far off you are. They do have laser transits where you set up that, and that's what they have for most of your. The nice thing about the laser transit is you can use them by yourself. So the original transit, this stick here basically had a ruler marked on it, and you look through here and it was like a magnifying scope. You could zero in, you could read the reading on the stick. The newer ones now, the stick actually slides up and down, and there's a spot right here where there's a window here you look through, and it tells you how far, and there's a sensor up here, and in that window it tells you how high the sensor is from the bottom of the stick. So then you wait till it'll beep slowly, and then when it gives you a solid tone, that means you're exactly on the laser. So you can do it. It's the same thing. That's a laser transit, not a laser level. By the way. A laser level is the thing you set up and it spins around and puts a line all the way around the room, or a straight line across the. No, the laser level just gives you a line that you can run straight lines across the room. A laser transit with its surveying stake are the combination that we're talking about here. Use the laser transit, yeah. Yep.
There's like almost invisible line that can trade up and down.
Yeah.
You could see the line. It doesn't have to spin.
No, it's not. Some of them aren't even visible at all. They're invisible signals that they send out. But anyway, that's a transit. All the transit does is gives you level. A theodolist a theodolite, depending on which one you're using. One's just a little more functional than the other. If you're looking at it from the top, not only does it have leveled, but from the top it has angles marked around it. And so on. So what you can actually do is you can actually set it on a reference line. So a lot of times what will happen, let's say I'm building a house, here's the lot, and here's the curb and the street here. Okay? I want to build a house and I want to make sure that my house is perfectly lined up with the street, that it's perfectly parallel. What would I do? Well, I could set up my theodolus right here, and I could shoot it straight down the edge of the street, down the curb, to get a reference line. Okay? Does that make sense? And now let's say that I want this corner of the house, if I'm set up at the corner of the lot with my theodolus, let's say I want that to be over 20 feet, so I have my setbacks, and back 30 feet from the road, from the edge of the road. What I'm going to do then, now my theodolus, I'm going to get set right here now off my reference line. What angle is that going to be? This is for point A here, by the way. For point A, what sides do I have here? Do I have the hypotenuse? I have the two legs, the opposite and adjacent, which means we're going to use a tangent. So tangent to that angle, what's the opposite side? 30, and the adjacent side, 20. So the angle is going to be the inverse tangent of 30 over 20. $56.31 degrees. What? I had 3 divided by 2. I left off the zeros. What's my distance? This is the square root of 20 squared plus 30 squared, right? .06 feet. So from this point right here, I'm going to measure 36.06 feet. 36 feet and 3/4 of an inch if you convert it to the nearest eighth inch. And 56.31 degrees from my reference line. That'll give me that corner of the house where I want it to be. So how about I call this corner B? Let's say this house is supposed to be 32 by 48. What would be my dimensions to corner B here? What's this dimension going to be? 68 feet. 20 feet plus 48 is 68 feet. What's this dimension going to be? Still 30. That hasn't changed. So for point B, my angle is going to be the inverse tangent of, what's the opposite side? 30. The adjacent side is now 68. So 23.81 degrees. Now we'll pause. Does everybody see where the 30 and the 68 came from here? In this triangle, opposite side, adjacent side. So now to find my distance again, it's going to be the square root of 30 squared plus 68 squared. $74.32 feet. What do you think? Good stuff? Find the angle and distance to point C and D in your notes for me. Okay, so for point C, this is 68 feet over to here again. This is now 62. 30 plus the 32 width. So we're dealing with, for point C, the angle is the inverse tangent of 62 over 68. .36 degrees. How many of you had 42.36 degrees? Good deal. Your distance is the square root of 62 squared plus 68 squared. .92 feet. How many of you had 92.02? What? Opposite over adjacent. Then for point B, or point D, it's 62 here, but it's down to 20 here. So for D, it's the inverse tangent of 62 over 20. So second tangent, 62 divided by 20. 72.12 degrees. How many had 72.12? And our distance is the square root of 62 squared plus 20 squared. .15 feet. How many of you had 65.15 feet? How many of you got this down and think you could do it on a quiz?
No.
Still trying to figure it out? Now, another thing that a theodolist can be used for is it can not only, like a transit can only measure level, but a theodolist can be used for this. Let's say you've got a tall tree over here, and you want to know how tall it is. You can set your theodolist up, and you can get an angle of elevation, they call it. So let's say that this is a 21 degree angle of elevation. The theodolist is set 5 feet from the ground to the center of the theodolist, and the center of the theodolist is 90 feet from the tree. How tall is the tree? Well, we're going to do this. We're drawing a triangle like this. This side is 90 feet. We are looking for this side, which is the opposite side. Of course, the 90 is the adjacent. So we're doing a tangent again. Tangent of an angle is opposite over adjacent. So we're going to fill in our angle as 21. So tangent of 21 degrees equals the opposite side over 90. So we're going to put this over 1 and cross multiply and divide. Tangent of 21 degrees times 90 gives us 34.55. Is that our height of the tree?
No.
No, why not? We got our 5 feet. So 34.55 plus 5 gives us 39.55 feet. What do you think? You measure from wherever the crown of the tree is, you measure from directly below the center of the crown of the tree. So whether the tree grows straight or not, you just make sure you're going straight down. Oh yeah, it's probably not exactly 39.55 because there's probably a slight error in your theodolist, error in your measurement, and depends on who's measuring it. There might be a major error. Who knows? Well, a bigger problem is what if there's wind blowing and the branches are moving? You can't, there's always going to be little factors that may cause slight error. But let's say for example, that there's a house that's sitting 50 feet away you know you've got clearance to cut that tree down. It's not going to hit the house. In your book on page 705, exercise 34-3, 1 through 12, and on page 708, exercise 34-4, 1 through 12. Go through applications of this using the theodolite, and the angles of elevation and depression. Make sure you do these because the quiz that is coming up on this stuff is probably the most missed quiz, most error-filled quiz of the semester. I want you guys to try them, then we'll go over them again. We've got another hour yet.